Hello, everybody, and welcome to the Microsoft Data and AI South Florida user group. My name is Adriano, and thank you for making the time to be here with us for another great presentation. And today we have data engineering brick by brick, an introduction to Azure Databricks by Chris Hyde. And before we get started, let us know. Use the live chat. Let us know where are you located. So, as the title says, the group is from South Florida, but I know that everyone from around the world comes and joins the presentations. Now, also, remember, like, subscribe, and click the bell. Keep us engaged here, get presentations exposed to the algorithm so others can also see it. Now, before we get started, just a quick house cleaning. Remember, is to enter your location using the live chat, but also let us know any questions you have. Use the live chat to enter your questions, interact with the presenter and the others in the group. We want to hear your thoughts, comments, and questions there. Next, again, just a touch, making sure also, your comments, make sure they're also in line with code of conduct, act properly, no abuse language, harassment, etc. So let me know if are you all ready for the data engineering brick by brick, an introduction to Azure Databricks. And here we have Said. Welcome, Said, from Toronto, Canada. Welcome. And as we are in the process welcoming, let's get Chris Hyde to join us here.
Hi, Adriano. Thanks for having me.
Thank you for being here with us.
My pleasure.
Making the time to be here to present and share some great knowledge here, some quite interesting presentation. Now, can you tell us where are you located at?
So today I'm in North Texas. I kind of split time 50-50 between there and Albuquerque, New Mexico.
All right, that's a good change there. I see that you like some of the warmer weather, if I may say.
Yeah, it's all right here, I gotta say.
All right, good thing. And tell us a bit about your role and about yourself.
So I'm an independent consultant. I work for myself, primarily business intelligence and analytics. The occasional DBA type stuff when that's needed. At the moment, I've got one big client in New Mexico, which is a large educational institution, and we're working on an on-premises database. So nothing super new there, but not new to me anyway, new to them. So I was just helping the businesses that I work with to get information out of all the data, out of all these ones and zeros they have. Let's turn it into something useful.
Absolutely. And if someone wants to reach out to Chris, check out the description section below. You have his LinkedIn and his Twitter information. And can you tell us just a high-level, quick bit about today's presentation?
Okay, so this is a true introduction to Azure Databricks, starting from presuming you've never even heard of it. I know there's in the current world things are changing so quickly in the Microsoft data platform that new products come and go all the time, and it can be difficult just to know exactly where a product fits in, what you can use it for. So I'm hoping to kind of demystify that for everybody.
All right.
If you're the type of person that's been doing Databricks for a couple of years already, this probably isn't the right level of presentation for you. So yeah, let's get that out of the way first.
All right. Appreciate the quick insight here regarding the presentation. And folks, remember, if you have a question, use the live chat, enter that question there. We're going to, during transition points, we'll relate to Chris here. And Chris, are you ready?
I'm ready. Let's go ahead and share the screen.
Are you ready?
All right, how does that look?
Excellent. Here we are.
Oh,
now it's
perfect.
all you, Chris. Thank you
All
very
right.
much, and folks. Enjoy the presentation. Use the live chat for any questions. Thank you, Chris. All you now.
All right, thank you. So welcome everybody. Good morning, good afternoon, good evening, wherever it is you might be from. This is me. I'm Chris Hyde, as we just covered. I'm an independent consultant based out of Albuquerque, New Mexico and North Texas. I also run the Albuquerque Data Platform User Group. We're virtual as well. We meet on the second Friday of every month around lunchtime, Mountain Standard Time. So yeah, please look us up if you'd like to see some presentations there. If you like the presentation, well, you've got my Twitter handle there. Please feel free to tell everyone how good it is. If you don't like the presentation, if you think there's some things that I could do better, well, that's what the email is for. But no, seriously, I know whenever I see a presentation, almost without fail, 5 minutes after the presentation, I think of a question I could have asked. Well, if that happens to you all, feel free to reach out. I'm probably more responsive on Twitter. That's probably the best place. But feel free to contact me either place. Send me any questions you might think of later. So I put this presentation together a little over a year now because I kept hearing how cool this new Databricks thing was. And then I watched a couple of presentations. I saw some videos, and they didn't really help me kind of get to grips with what Databricks, what role it plays. What I was really looking for was kind of a true intro, kind of assuming that I didn't know anything. I just, fill me the very basics, tell me where and tell me where to go next. So that's the kind of presentation I put together for you all. It's the kind of presentation that I wish I'd been able to see a couple of years ago. But if you've been doing Databricks in production already for a little while, this is probably at a pretty basic level. So feel free to stick around, ask any questions. I'd love to help out, but just know that the presentation isn't targeted at you necessarily. So here's what we'll talk about today. We'll get, obviously I want to teach you all what Databricks is, but before we get started with that, I want to take a step back and sort of answer the question, what is data engineering? Right, we've been talking about this a lot the last year or so. It's a term that keeps coming up. So I want to make sure that everyone on the call is familiar with what I mean when I say that. But then just to make sure, I want to make sure we all know what a data warehouse is as well, particularly if we use the term modern data warehouse. What does that mean compared to maybe the on-premises data warehouse that a lot of us have been using for a while? Let's just get everything back to kind of ground zero, make sure we're all on the same page, and then we'll jump into really what Azure Databricks is. We'll use some notebooks and some demos. In Azure Databricks, we'll work with some very simple, and we'll look at how to do this stuff in a collaborative environment for analysis. So let's get going. So at its most basic level, a data warehouse is a centralized repository of integrated data from one or more disparate source systems. And so usually we've got current and historical data, and we end up using it for reporting and analysis on that data. So this slide here is an example of a traditional data warehouse architecture. And let's say we're doing it in the Microsoft stack. We might be taking data from our source system to our data warehouse using SSIS integration services. And then we might display that for reporting using SSRS reporting services. We might put a tabular or multidimensional model using analysis services on that and either report off that, display it through Excel. We've got a number of different options there, but that's kind of the traditional way that we've looked at things in our industry. But now we're starting to move towards this so-called modern data warehouse architecture. So, we're taking our cues here from the world of big data. And I think a lot of us would agree that the term big data is a little buzzwordy at this point. But, truly at its heart, it's about the 3 V's. Now, some people will tell you 4 or 5 V's, but there's really 3 key V's to keep in mind about big data, and that's the volume, the velocity, and the variety of the data. And what we're seeing, even those of us that, excuse me, don't have the true, the volume and velocity of true big data, a lot of us do have the variety. That data coming in from so many different types of sources now. You can see on the left, we've got web logs, unstructured. We've got different types of files that may be unstructured. They may be fairly rigid like CSVs, semi-structured like JSON data. We might have a media file. And we might, obviously we'll be pulling from relational and, maybe NoSQL sources as well. So in the past, we spent a lot of time transforming those sources upfront, putting them into a rigid structure, storing them away in our traditional data warehouse. But that's not necessarily the way we do things these days, especially now we've got access to relatively cheap, distributed, large-scale parallel computing. And we can, look here a little bit. We can see, how that architecture might blow out as we start including, things like streaming and real-time big data. So that's a little bit of, when we're talking about modern data warehouse, where that is. So then what is a data engineer? Well, that's really the person responsible for ingesting the data, transforming it, presenting it, modeling it within that modern data warehouse architecture. And it's one of the key roles. Data science was the big buzzword 3 or 4 years ago, until people figured out that really 80% of data science is not the designing the machine learning models. It's really the data engineering. It's the shaping, cleaning, transforming the data. In a way that's analogous in traditional BI. 80% of traditional BI is just ETL or ELT. It's not the presentation layer. It's the moving parts of the data. So that's really, why it's so key these days. And also, many of us may have come from a traditional DBA background, and that background is gradually being, automated out from under us. That role is definitely changing. If you've been a traditional DBA, you probably spend a lot of time, setting up your backups, validating that those are happening, or setting up high availability. Log shipping is great, not necessarily the simplest thing to set up, but now in the cloud world, you can get wide, geo-replicated redundancy with just a few mouse clicks and a swipe of the credit card. Even performance tuning, that was kind of the last bastion of the traditional DBA. We've got things like intelligent query processing, adaptive query processing, and they're starting to mean that we don't need a traditional DBA for nearly as much stuff as we did a few years ago. So if you're that kind of data professional, you're just know that the roles that are out there and available are changing. So you may need to move away from more of the traditional DBA into a data engineering role in the future as those type of roles kind of take over. So we've talked about the data warehouse, we've talked about data engineer. So now we can actually get to the task at hand, which is what is Azure Databricks. Okay, well, the very basic level, it's the Azure implementation of a cloud-based product called Databricks. Okay, so not telling us too much. This Databricks product, it's really just a managed version of something called Apache Spark, with extra features on top to help you implement it, help you manage things. And that's not necessarily helpful yet, right? So what is Spark? And that's the key. So it's a tool, it's a framework for processing very large amounts of data by distributing that processing across a large number of machines. Now, sure, as we'll see today, we're working with relatively small files in our demo purposes. But the beauty of Spark is that you can do that large-scale distributed data processing on hundreds, thousands of files, or very, very big files. And it will split that out, all that data processing out among multiple containerized computers that are set up. So you're distributing that data processing, you're going parallel very easily. And what that means is you only actually need to pay for the compute power that you actually use. Because as soon as you're done with the machines that make up that cluster, you can just turn them off. Right? If we're in the traditional on-premises world, you're probably dealing with an SLA. You've got to get all your data processed between a certain time when the end of the day happens and the beginning of the day happens. Maybe you've got a 2-hour window to process everything in. So you have to have a big enough machine to process all your data within 2 hours. Well, and then what happens to that machine? Well, it just sits around idle. You never hit the CPUs, at 100% like you do during the ETL period. So you really had to pay a ton more for the server. You needed a much more powerful server for that 2-hour window that never gets used. Well, in this product, you just spin it up, process all your data as wide as you want, tens, hundreds of machines even. Just pay for what you use and then shut all those machines down and forget about them until the next time you need to run the ETL. Now, Spark itself is fully open source. So you could set it up yourself, but you need to be an expert in networking and container technologies, and of course have all the ability to spin up all those VMs or containers. You have to have that knowledge, but because this is a managed product, Azure Databricks lets us do all of that kind of stuff with just a few mouse clicks. And because it's in the Azure cloud, we spin things up very quickly. Even very large clusters that have, as I said, dozens, hundreds of nodes, we just run them for as long as we need, turn them down again. So at its heart, we're just talking about a massively parallel data processing tool that we can turn on when we need. And so if we go back to this, we can kind of see the Databricks, it's right in the center of everything. So I like to think of it, going back to the on-premises world, it's our T in our ELT solution. So ELT, for those of you who haven't heard, stands for extract, load, and transform. And that's what we do with our data. We extract it from our source systems, and we load it into something else. And from there, we transform it into the shape that we need, whether it's a dimensional model for doing analysis, or it's into a specific shape to feed into a machine learning algorithm. That's where we do that transform, that T. And that's the important thing. So maybe in an on-premises world, we used SSIS to do the extract and load into our staging area. And in Azure, we might use Azure Data Factory for that same. But then where we would have had a lot of complicated T-SQL to do our transforms, here we put Azure Databricks in to do our transform. So it's really, that's really the best place, is this massively parallel transformation engine. Now, I'll also show you in our demos that we can also use Databricks as sort of a shared analysis environment for our team if we want to do the kind of data analysis that you'd use Python or R or Scala for. It's a good place to do that among all of your team. That's good too. So I'll show that in the demo as well. And then how do we control what's going on in our Azure Databricks clusters? Well, we use notebooks. Now, a lot of you might have seen notebooks already. We first saw them, at least in the Microsoft world, really with Jupyter to run our Python code. And then we started seeing SQL notebooks in Azure Data Studio. Well, now we've just another type of notebook, Apache Spark notebooks. Everything works the same. You can step through the cells. And here's what some of the things we're doing. We're reading and processing either very large files, other data sets, or very large numbers of files. And we can explore the data in them, write queries against them, do our analysis, create pretty visualizations against them. If we've got a lot of different types of data in our data lake, I mentioned weblogs or different types of CSVs, JSONs, any kind of different formats, well, we're bringing them together and transforming them into single, coherent data structures. We can also process live streams of data. We can use Azure Databricks to, kind of orchestrate our machine learning models. If we're using, the Azure Machine Learning Studio suite, I guess. And we're not just limited to tabular data. We can use graph data sets like social networks. And don't worry that you necessarily have to learn a brand new language to use them. If you've been using Python or R to do your analysis, great, you can do that right in Spark. You can use Scala, that was sort of originally what it was designed to use. But you can also, if you're coming from a data background like I am, just use regular old SQL. So it's really a fairly easy ramp up. So I know I've been talking. Adriano, have we had any questions so far that this would be a good time for me to answer? Okay, well, I'm not hearing any questions, so let's go ahead and jump into the demo. So I'm going to jump over here to my Azure account. And the first thing we need to do is create an Azure Databricks workspace. This is like our Databricks appliance that's deployed to our Azure subscription. So I'm going to create a resource. And of course, there's hundreds of things. I'm not going to try and dive through the menu to find it. Just start typing in Databricks. And we'll hit the create button. So let's give this, let's pick one of my resource groups to deploy it to. Give it a name. Choose my region. I'm in South Central today, so this is probably a good bet. And we can do standard or premium, or there's also a trial version. If you want to, try this out for yourself after the talk today, you can go ahead and basically all the compute is free for 14 days. Now, it doesn't necessarily cover all the I/O traffic, but just know that you can play with this type of technology very, very cheaply using the trial account. So we'll go ahead, we'll go to review and create. Everything looks good. So I'll hit my create button here, but like with a lot of other Azure resources, it's going to take a few minutes to set up. So kind of like any good cooking show, I've gone ahead and done that ahead of time. And we can go to our Databricks service. We see it's active. And we go ahead and we launch the workspace. And this opens up, and I've already got it open up here. This is the browser-based environment with which we're interacting with our Databricks code and our clusters. So the first thing we have to do is we have to go ahead and create a cluster. We have to define the machines that we're going to be working with. So let me go down to compute here. Now I've got one set up here, but we'll show you through creating a new one. So we'll give it a name, pick standard or high concurrency, or maybe single node if we really just need sort of a serverless Python experience, say. We'll go ahead and do standard. We've got kind of a dizzying array of versions of Databricks here that we could choose, but it's all about which version of Spark and then which version of the Scala language. And then if we're doing heavy duty machine learning, we might want to look at one of these options that use the GPU processing for some extra power. So we'll just use the basic here. This is important. If you're running standard, make sure you have this terminate after a certain time of inactivity. You will build up a cost if you don't shut your clusters down. I'll get to the cost in just a second here. And then we choose the number of machines we have. So we're always going to choose a driver and then a type of worker node. I've chosen very lowest level here for our demo purposes. Got a DSP v2. It's got 14 gig memory and 4 cores. And I'm going to say we're going to have between 2 and 4 of those. So if we've got a small job, we might only need 2. If we've got a larger job, I'll let us go up to 4 here. And that's going to give me an estimate here of about 3 dBUs an hour. Well, that's a Databricks unit. And the amount that costs can vary between region. The best thing to do, I should have pulled this up beforehand, is just look up Azure Databricks pricing. And hopefully this should be quick. And you will put in your region, and you'll see something like this. For our all-purpose compute, this is just what we're doing when we're going in here to explore, run things manually. It's about 40 cents per dBU hour. So we saw here, this is about 3 dBUs an hour. The way we've got this set up, we're only looking at about $1.20 an hour for compute time on the standard tier. Now, if we set this up to run a scheduled job, we're actually going to cut the price pretty significantly down to 15 cents per dBU hour. Now, of course, as we schedule this up, we would say 12 workers, or we might be tripling the cost if we're really using all of those worker nodes. So I'm going to go ahead and create cluster, except again, this takes 3 to 4 minutes to actually set our cluster up and running. So I've already gone ahead and done that beforehand. Here's our cluster, the 12 active cores, and that's our active dBUs an hour. So we get a good sense of how much this is costing us just to run the demo today. So now that we've got our cluster, we need to set up a notebook to send it instructions. So what I've done here today, I'm going to use a couple of publicly available notebooks, so that you all, if you want to use this, you can try out the same notebooks. Yeah, I don't want to make you have to, set up your own data lake, set up the security between, just to start, playing with Databricks a little. The easiest way is to use these publicly available ones. So I'm going to share these in the chat interface that I have with Adriano, and I think then that he can share them out to everybody here in YouTube land. So here's the first one. I'm going to go into workspaces. I could choose to make it a workspace just for me, but I'll make it a shared one so that anyone who has access to this Databricks resource can use it. And I will do an import, change this to URL, drop in the URL and hit import, and it'll create the notebook for us. Now, I've already done this, but when you're wanting to try it at home, that's how you'll get to what I'm looking at today.
Chris, we have a question.
Okay, this is probably a good spot for that.
All right. Folks, I just added to the comments the link provided by Chris. I will also enter that URL in the description of the video. So if you're coming after, you see I'll create a section for resources. Now, back at the range, we have a question from Sridhar. Pardon me for any mispronunciation. The question is, how is Databricks better compared to Jupyter notebooks?
So as far as the notebook experience itself, it's very similar. So if you're doing any kind of analysis, it's a very similar experience. So I think you'll get a sense of that in the demos. But you probably wouldn't use Jupyter to do any kind of really huge heavy lifting, right? If you're using regular Python, you're limited to a single thread unless you're using some very specific packages that allow you to go multi-thread. So if you're wanting to really do this massive parallel processing that Azure Databricks is really good for, that's the biggest difference, right? You can set up, we're just going to look at bringing in a CSV file here. You could do that just fine in, regular Jupyter notebooks. But if we've got, hundreds of thousands of CSV files coming in every hour from our Internet of Things, sensors that might be out there, Jupyter probably isn't the best place to, handle hundreds of thousands of files per hour. We need to go very wide for that kind of thing. So I hope that answers the question. If it doesn't, please go ahead and post a follow-up, and see if I can answer that a little bit better for you if that didn't work. All right, so our first example here, this is probably a pretty common occurrence, right? We're working and a bus comes to us and they say, hey, we've got a new file from one of our vendors. We threw it in the data lake just to put it somewhere. Can you take a look at it, figure out what it looks like? Yeah, pretty standard stuff, right? So let's start off. And actually, before we start, actually, let me point up here. See that our notebook here is in Python. So all the coding examples we'll see are in Python. But we're also allowed to put something called Markdown here, which is like a sort of a stripped back HTML. So it lets us, kind of make our notebook self-documenting as we go through. So it's not all code, it's also, instructions or things to point out. Now, one of the things that's a little different from regular Python, anytime you see a percent symbol, that means it's a magic command. It's, it might be a shorthand way of doing something. In this case, %fs is the magic command that says this is going to be a file system task. So we're just going to take a look at the directory here, take a look at our files. Okay, this is a very simple, TSV file. It's big, but it's not huge, about 256 meg, I think. Let's look at the beginning of it. So another magic command for the head, and we'll look at the beginning of that file. And okay, we can see it's tab separated, which probably isn't a surprise given the TSV extension. We can see it's pretty simple. It's just 3 columns. So this is just Wikipedia page view data, timestamp, whether it was the mobile or desktop version of Wikipedia, and the number of requests. So let's start. Let's go ahead and bring it in. Should be pretty simple. We'll make a variable to have our file. And we'll use Apache Spark to just read it in. We know it's tab delimited, so we'll add the option to make the separator be a \T. And let's bring that in. Kick off a job. And we pulled this into a data frame. So when we say data frame, we're really just meaning tabular data. Data like a table we might use in SQL. It's got rows and columns. Standard data like we think. So this is kind of our equivalent of like an in-memory table here. Let's see what that table looks like. Well, we've got 3 columns. They're all strings, and they're named C0, C1, and C2. Well, that doesn't look terribly useful, does it? So let's see what happened. And let's see if we show what's in that data frame. Oh, we can see right away, oh, there's a header row. We didn't tell it that there's a header row. So let's add that option. And we'll just print the schema right away. I'm bringing it in this time. No need to do that in 2 steps. Okay, so we've got our column headers. Perfect. But we know that our data isn't all strings. One was a timestamp, one was an integer value. Well, let's make the data. We can actually tell Databricks, take a look at the data that's there and infer a schema from it. Look at all the data, figure out what the best data types are. So excuse my little furry visitor there. Okay, we can see that there it's figured out. Okay, we've got a timestamp, we've got a string, and we've got an integer value. But it took about 20 seconds to bring that in, which that's not great. I mean, it works for one file at a time, right? But the beauty of Databricks, as I said, is we're going massively parallel. We might have, thousands of these files coming in. If we looked at the, we saw that the timestamp was down to the second. So we might have, 3,600 of these files, an hour, or one file an hour with 3,600. But every hour of every day, we've got a new file. We can get up to a very large number of files very quickly, and at 20 seconds per, that's going to take a long time. That's all because of this infer schema. So what we want to do is define the schema up front, and you'll see how good that is. So we're going to create basically a structure, a data structure, based on a Python list, note the square brackets. And within that structure, we've got some different fields. And we'll go ahead and define that structure. And then rather than infer the schema, we'll use that new structure as the schema. And instead of 20 seconds, it takes less than a quarter of a second. So, much, much more efficient to do. And, of course, we're never looking at one file once. We're always looking at it as a precursor to all of a sudden we're going to have thousands of these files coming in, right? So that's why, we want to figure out the best schema and use that on our report. All right, so CSV data is pretty easy. Now within that group of notebooks, there was another one about reading JSON data. And if you worked with JSON and SQL Server, you might find that, well, it's a little bit difficult to use, not the easiest thing to parse. It's much easier in Databricks. So again, let's look at our file system. All right, there's our JSON file. This is all edits of Wikipedia. All right, let's see what that looks like. And so we can see this is semi-structured data, right? Because there's so many different things you can do to a Wikipedia article. You can add text, take text away, change text, add a picture, add a sound file, move things around on the same page. It would be very difficult to define a rigid data structure that easily, contains all the different edits you can do to a wiki page. But if you self-describe the data with tags, like in the JSON format, it becomes much more manageable to track that data. It just can become more difficult to parse. So again, let's go ahead and read this data in. And we've inferred a schema here. And we see, look, this field actually has a sub-level below it. Okay, what does that look like? Oh, sorry, let me back up a second. So if you've been using this in SQL, you may find that it can be difficult to query JSON data to dig down into those different levels. But in Databricks, it's much easier. So we're actually going to do something that is probably analogous to something you might have done in the SQL world. We'll create a view. And once we've created a view on top of that, we can actually write basic SQL queries here. Now note we've got another magic command here. And this is %SQL. This is saying that even though this is a Python notebook, treat the code in this cell as though it was SQL data. Or sorry, SQL code. So we can then do a simple select. And we see, wait a second, that geocoding, kind of as we would have expected from the schema above, that's not a single field, it's a little JSON string in there. Well, how do we drill down into that? With Databricks, it's just as easy as saying geocoding.city, geocoding.latitude to dig into that next level. Now we've got that view set up. So easy to parse out our JSON data here. And similarly to the last section, we're never going to get just one JSON file. We're always going to get, a whole bunch we'll have to work with eventually. So we don't want to infer the schema every time. We want to define our schema. And again, this is another structure. It's a big list. But note that one of the fields here is itself its own list structure. So a list within a list. And that's how we've defined that extra level. And that'll allow us to, again, read things in, incredibly quickly. So that's how we deal with a couple of data formats you might be used to working with. This is probably a good time to any other questions that may have come in.
No, I don't see a question right now, but folks, remember, use the subscribe and use the live chat to enter your questions. All right, back at you, Chris.
Okay, great. So we're going to use a different notebook. This one I'd say provided by the Databricks company themselves. So let me pop this into my chat with Adriano for him to add to the larger chat. And we'll go on and switch over. And this is the kind of instance where we might be doing some analysis on our data, but we're doing it as part of a larger team. We've got one notebook, but we've got multiple people working on the notebook, at a time. There might be one person that's really good with, figuring out the best regressions to use to get good numerical answers. And we've got somebody else on the team who is a whiz with visualizations to get things that look good and really communicate the story. So we can have, this notebook out here, available for multiple people to work on collaboratively, at the same time. So it's a great way to have that shared analysis environment. And you'll see that this is in Scala rather than Python, so we'll mix it up a little bit. And what we're going to look at here today is some flight data. So we've got, let's go ahead and bring things in to show you all what the data looks like to give some context. And when we get down to the display, we'll have kind of a better sense of what we're looking at here.
We have another question there when we have a minute, Chris.
Okay, yeah, perfect.
All right, so we have Marcos Soeiro. He wants to know, can we deploy our Databricks notebooks into a production pipeline?
You certainly can. You've got really two good ways of doing that. You can, so if you're productionalizing them, you can actually schedule jobs right from within the Databricks environment. Or you can call them from, say, Azure Data Factory if you're putting them in the context of a wider pipeline. So you can definitely call Databricks notebooks from there. All right, so back to our demo. And this is the type of data we're looking at. We're looking at flights, nonstop flights from a source airport to a destination airport, and their abbreviation, how far they went, and a lot of the examples we'll look at our delay. So if our delay was negative, the flight was actually left a little bit before time. If it was 0, flight left bang on time. Flight was 1 minute late, so not too bad there. If you think about flight data and we start visualizing it, think of a map. This is all American flights. We think of a map of the US with little dots as the cities and little lines between the dots. That's our flight. Well, that really looks like a graph data. The cities, the airports, there are nodes or our vertexes, and our edges are the actual flight. So the information about the city, so the name, with the state that it's in, its 3-letter code. That info goes in the node, or again the vertex, depending on which graph terminology you're using, and data about the flight itself, when it was, the trip ID, the delay, that will attach to the edge. And if we build that into graph data, we're going to be able to traverse it and do some different things than if we were in regular tabular data. So one little wrinkle here. So we talked about data frames in the last examples. Well, we're going to use a special version of a data frame called a graph frame, designed specifically to hold this graph data. But the library that allows us to use the graph data frame is not part of our default Databricks installation. So we have to come into our cluster and go to libraries and actually add it manually. You see it, I've gone ahead and done it here already. But if we were going to bring in another library from new, or bring in a Python library, we'd probably use PyPI. Scala libraries are in Maven. So we're, I just looked in here. Graph frames, found the one I want. And I just have to be careful not to instinctively hit select. It's easy to hit because I'm excited that I found the one that I wanted to use. But look at this drop down. See all this dizzying array of releases? Well, this is just like when we had the array of choices for our cluster. We've got a different version of the package depending on which version of Spark, which version of Scala we're using. And you only see the version of Spark here, but if you hover over, you can see the version of Scala. So we want to make sure that we're picking a version of graph frames that is compatible with the version of the other libraries used in the cluster we installed. Now, this time I got lucky. It just happens the top one in the list is the one that I've chosen, but I know I've made the mistake multiple times that I've accidentally installed one that's not the right release that's compatible with the cluster that I've used. Okay, so that's installed and running now. Let's go back into that notebook. And where were we? Okay, we're down here. Yeah, so we've got here, a data frame that looks pretty traditional. It's our, columns and rows. So let's turn that into our edges and our vertices. And as we talked about, the vertices will be the info about the airports themselves. The edges will be information about the flights. And we'll go ahead and combine those into a graph frame, and that will allow us to write some really good queries. Let's start with some simple stuff. Let's just, how many airports are we looking at? How many nonstop flights? So we've got about 300 vertices, 1.4 million edges. So pretty good. So out of all these flights, what's their longest delay? We've got one flight here. If actually more than a day in delay. I'm certainly glad I wasn't on that flight. Well, how big of a problem is this? Let's throw a filter on here just to do a quick count of the number of flights that are on time or early versus the number of flights that are delayed. Okay, yeah, not too bad, maybe about 60% on time or so. So let's start drilling down. Let's add another filter. Let's just look at flights that are leaving San Francisco. All right, so which are the destinations that have the highest average delay? Oops, help if I actually displayed the results. Now we can see our flights from San Francisco to Oklahoma City, average delay is almost an hour. So you maybe want to take that into account if we're planning our flights from there. Now let's flip it around. What destinations have delays in general? Now let's show this as a map. Well, we can see that we've got a lot of delays. Our delay percentage in South Dakota, New York, pretty high. Arizona, not as much. Well, let's look at another city. Say we're leaving from Seattle. We don't mind small delays. We're only concerned about delays, more than 100 minutes. Where should we be worried about? Okay, definitely we should be worried about flights to California. Now, of course, this isn't telling us the full story. Maybe we've got, way more flights to California than anywhere else. So that's simply why we've got more delays. Is it that we don't have any flights at all to Lincoln, Nebraska? Or maybe it's, for some reason, all those flights are on time. Either way, it's nice and it's pretty, but it doesn't necessarily tell us a lot. Now, skip through a few of these because I know I'm about at the hour mark already. I want to show some searching, right? Let's say we're in Seattle and we want to go to San Francisco. We want to find out, are there any direct flights? So are there ones where the max path length, i.e. just one edge between Seattle and San Francisco?
Are you all enjoying the session? Do not hesitate. Drop a note here on the live chat. Let us know that you want Chris to keep going here. So Chris, you don't have to worry about the time there for 60 minutes, all right? Thank you.
Okay, great. Yeah, and so we can see, we've got a whole bunch of flights from Seattle to San Francisco. But let's say we wanted to go from San Francisco to Buffalo. Do we have any direct flights? Nope, nothing at all. Well, how about flights with one stop? So they've got a path length of 2. So one edge from San Francisco to one node, and then another edge from that node to the Buffalo node. Let's see if we've got some of those. And they say Minneapolis down here, and I'm sure there are some, but usually we come up with the Boston ones first. So yep, we can fly from San Francisco to Boston and back over from there to Buffalo. All right, so that's pretty much all I had planned to show you today. I wanted to be respectful of your time. Just wanted to leave you with a couple of resources. So this presentation should be up on my GitHub. Well, so there's a couple of good tutorials now on Microsoft Learn. They've really done a great job the last couple of years of making tutorials that are really useful, really more of a real world situation. So there's a couple examples here. I'd encourage everyone to follow those. Remember, you don't have to use the standard or premium. You can use the trial version of Databricks. So that's going to allow you, if you've got an Azure subscription already, to use those for free. And then I always like to sort of leave you with a link to this video series by a company out of the UK called Advancing Analytics. They're really experts in Databricks and Spark and that type of data engineering. And a year or so ago, they did this series called Month of Databricks. And for a month, every day or every other day, and I think there's 20 videos in total. They did just a short bite-sized 10-minute video. So this is a great place if you liked what you saw today and you want to start getting deep. Start digging into these videos. They're not a huge time commitment, but you'll learn a lot right off the bat by going through these. So that's me for today. Yeah, I'm here if you've got any last questions. It would be great to hear them. If not, if you think about them later, please go ahead, hit me up on Twitter or by email. I'd love to talk to you.
Awesome, Chris. Thank you very much. A great presentation there. And folks, let us know. Enter your question in the live chat. We are here for another minute or so. And do not hesitate. Drop a comment here in the live chat. And remember, like, subscribe, and enter a comment. So let us know if is Databricks the type of presentation topic you like. We will also have another presentation we're going to cover on the more to the end of the month. We'll be covering Delta Lakes on Azure Databricks. So also, let's take a look here. Yes, question, Chris. Is it mandatory to use Scala in our notebooks, or can we reuse Python code from other notebooks?
No, you can definitely use Python. So the CSV and the JSON demo, that was using Python. So you can go ahead, you can develop stuff and then, put it in here when you're ready to operationalize it. That's just fine. You can also use R if you're more comfortable with R instead of Python, that's fine. And as we've seen, you can intersperse SQL in there as well. So you can mix and match. You can use, Scala in a Python notebook or Python in a Scala notebook. You can go back and forth with there too. So it's really whatever is easiest for you.
All right, great. And Marcos, let us know. I believe the question has been answered, but let us know if you have any other questions or anyone else has any other question there. And I'll be adding the resources that Chris has shared here with us to the description below. And Marcos says, thanks. Will it impact the performance?
I'm assuming that you're asking specifically, will the choice of language impact performance? And no, it won't.
All right. Thank you, Chris. And thank you, Marcos. Awesome. Here we are. Fantastic presentation here from Chris. And you have Chris' contact information right now on the screen. So if you have any questions, you can enter in the comment section below. And you can reach out to Chris at ChrisHyde325 on Twitter and ChrisHyde325@gmail.com via email. All right, Marcos, thank you very much for the positive feedback there. He's saying thank you very much, Chris, for the presentation.
Thank you.
All right, folks.
Okay, well, if that's it, thank you everyone for letting me talk at you this evening. Adriano and the rest of the group for letting me speak. Really appreciate it.
Absolutely. Thank you very much there, Chris. And folks, remember, like, subscribe, click the bell, and thank you for making the time being here with us on another presentation of Microsoft Data and AI. Remember, check out our meetup for our next presentation. And by the end of the month as well, we will have a book raffle covering Azure Databricks or involving Azure Databricks as one of the technologies in the book. Thank you all. Have a great day there and a great week. Bye-bye.
Hi, everyone. Thank you.